Hi there, and welcome to Azure VMs Made Easy. This is a quick-hitting course designed to walk you through every setting and option you'll encounter when deploying a Windows virtual machine in Microsoft Azure. Whether you're brand new to Azure or someone who's been working with virtual machines for a while, this course is going to give you the clarity and confidence to make the right decisions as you deploy and manage VMs in the Azure cloud. Throughout this course, we're going to take a tab-by-tab look into the entire VM creation process, from configuring the Basics tab, where we set up key details like region, size, and image, all the way through disks, networking management, monitoring, advanced options, and tags, so you'll get clear explanations of every setting, including what it does and when you might want to use it. As we look at the different options, you'll learn when a setting makes sense and when it might not. By the end of this course, you'll be able to confidently deploy Windows virtual machines in Azure, fully understanding every choice you make, from cost to performance to security. So, if you've ever felt confused by all the options when creating an Azure VM, you're in the right place. Hi there, and welcome to Configuring the Basics. When deploying a new virtual machine in Microsoft Azure, the portal presents several tabs along the top, including Basics, Disks, Networking Management, Monitoring, Advanced Tags, and finally, Review and Create. This lecture specifically addresses the Basics tab, where I'll explain each available setting, its purpose, and why you might use it. At the top of the Basics tab, you'll find the Project Details section. Here, Azure asks you to specify your subscription. Your subscription determines how resources are billed and managed. Selecting the correct subscription is essential, particularly if your organization maintains multiple subscriptions for different departments or projects. Resources deployed within a subscription are grouped for billing purposes, so accurate selection simplifies budgeting and management tasks. Just below subscription, you'll specify a resource group. Resource groups act as logical containers, organizing related Azure resources that typically share a similar lifecycle, permissions, or policies. For example, if you're working with multiple components of a single application, like web servers, application servers, and databases, these resources often fit naturally into the same resource group. From here, you can choose an existing group or create a new one. In the Instance Details section, the first item is the virtual machine name. The name entered here is used both as the Azure Resource Identifier and as the guest operating system's host name. While you can later adjust the host name within the OS, the Azure Resource Identifier itself remains fixed. Keeping both consistent helps prevent confusion. Remember, the virtual machine name must be between 1 and 15 characters, with no special characters permitted. After naming your virtual machine, choose the region for deployment. Typically, you'll select a region closest to your intended users, which helps reduce latency and enhances performance. Keep in mind, certain virtual machine sizes might not be available in every region. Azure will alert you if the chosen size isn't available in your preferred region. Below the region, you'll encounter availability options. This setting lets you configure redundancy and resiliency for your deployment. Options include availability zones, availability sets, virtual machine scale sets, or no infrastructure redundancy required. Availability zones protect against entire data center level outages by distributing resources across physically separate data centers within a region. Availability sets protect against hardware or software failures within a single data center. Virtual machine scale sets enable automatic deployment and management of multiple identical VMs, ideal for load balancing and scaling. Immediately following availability options, you'll find zone options. Here you can let Azure auto-select an availability zone or manually select a specific zone within your chosen region. If precise control is needed, manually choosing a specific availability zone ensures your VM resides exactly where you want it. Below this is the security type setting. Choices include Trusted Launch Virtual Machines, offering enhanced security features like Secure Boot and Virtual TPM, or Standard, providing basic security measures. Trusted Launch is typically recommended to strengthen your VM's overall security posture. For the operating system, the image setting allows selection from several pre-configured options. Common choices include Windows Server, Ubuntu, Red Hat, and other distributions. Following the operating system image, you'll select your VM's CPU architecture through the VM architecture setting. Available options typically include x64 or ARM64. The standard x64 option supports most workloads, while ARM64 can offer efficiency advantages for certain specialized scenarios. Azure Spot Discount is another setting available here, offering discounted compute capacity. Spot VMs utilize surplus Azure capacity at reduced prices, but can be reclaimed by Azure at short notice. Because of potential interruptions, Spot instances are best suited for test, development, or non-critical workloads rather than essential production environments. Just below the Spot VM option, the size setting allows you to determine your virtual machine's hardware configuration, affecting CPU power, memory capacity, performance, and cost. Be mindful that your chosen size influences the cost and capabilities of your VM, and not all sizes are universally available across all regions. Another available feature is VM hibernation, represented by a checkbox. Hibernation lets your virtual machine quickly save its state for rapid restoration later. However, not every VM size or operating system image supports hibernation, so compatibility should be verified before enabling this feature. In the Administrator Account section, Azure prompts you to specify a username and secure password for your VM. Always choose strong, unique passwords and avoid common usernames like admin or administrator, enhancing security from the outset. The inbound port rules settings control external access to your virtual machine. Azure defaults to restricting inbound public access for security reasons, but you can open specific ports, such as Remote Desktop Protocol, which is typically used for Windows machines, or SSH for Linux. Be cautious, though. Publicly opening ports poses security risks. In production environments, you should manage inbound traffic using Azure Network Security Groups to maintain a secure posture. At the bottom of the Basics tab is Azure Hybrid Benefit. This option allows you to apply your existing Windows Server licenses to Azure, significantly reducing licensing costs. If your organization owns eligible licenses, enabling Azure Hybrid Benefit offers considerable savings. And with that, this covers all settings shown on the Basics tab when deploying a VM. In the next lecture, we'll explore disk settings in detail. I'll see you there. Welcome back. In this lecture, we'll explore all of the options and settings available on the Disks tab when configuring an Azure virtual machine. On the Disks tab, Azure provides various settings that help you manage storage encryption, disk performance, redundancy, and overall storage management. Let's step through each of these settings so you clearly understand their purpose and how they're used. At the very top of this tab, you'll see the VM disk encryption setting called Encryption at Host. When you enable Encryption at Host, Azure automatically encrypts all of your managed disks, including both the operating system disk and any attached data disks, right on the host before the data is written to storage. This provides enhanced security, making it valuable for workloads that require strict encryption compliance or regulatory requirements. Keep in mind, though, that this feature needs to be explicitly enabled and registered for your subscription. If it isn't enabled yet, Azure will display a notification letting you know. Moving down, you'll find the OS disk section. Here you specify the properties of your virtual machine's operating system disk. The first setting you'll encounter is OS disk size, which defaults to the standard size provided by the image you selected on the Basics tab. It's typically 127 gigabytes. This size usually suits most situations, but if your environment requires more space for applications or data, you can easily adjust this setting. Right below that, you'll see the OS disk type, which provides several storage options that are tailored for performance, reliability, and cost management. Azure categorizes these disk types into two groups. They are locally redundant storage and zone redundant storage. With locally redundant storage, your data is replicated within a single data center in order to provide resilience against local hardware failures. With this setting, you have a few different options. For example, Premium SSD offers high-performance storage, which is ideal for critical workloads like enterprise applications or databases. Standard SSD provides balanced performance at a lower cost, making it suitable for lightly used applications, web servers, or for development environments. Lastly, Standard HDD provides the lowest cost and is best suited for backups, non-critical data, or scenarios involving infrequent data access. Zone redundant storage replicates your data across 3 separate availability zones within an Azure region, which greatly improves resilience and protection against potential data center level outages. Zone redundant Premium SSD is recommended for production environments requiring both high performance and strong resilience, while zone redundant Standard SSD is a good choice for lightly used enterprise apps or web servers where higher availability is still required, but top-tier performance isn't critical. The checkbox for Delete with VM is found immediately below this. This allows you to specify whether your operating system disk should be automatically removed if you delete the virtual machine itself. Selecting this can help avoid unnecessary storage costs in temporary or testing environments, but in scenarios where the disk must be retained independently of the VM, it's best left unchecked. The key management setting follows. This setting determines how Microsoft Azure manages encryption keys for your disks. By default, Azure uses platform-managed keys, which provides ease of use and simplicity for most scenarios. However, if your organization has stricter compliance requirements, you have the option of using customer-managed keys, which allows more direct control over the encryption keys. Next, you'll see an option labeled Enable Ultra-Disk Compatibility. Ultra-Disk provides Azure's highest performance storage, delivering really low latency and high throughput. It's ideal for workloads that demand peak performance. High-performance databases or real-time analytics apps would be good examples of these kinds of workloads. Be aware, though, ultra-disk storage significantly increases costs, and availability can vary depending on your chosen region and VM size. Below the OS disk section, there's the Data Disks area. This is used to attach additional data disks to your virtual machine. While every virtual machine automatically comes with a temporary disk designed for short-term storage, adding dedicated data disks is beneficial for storing application data, database files, or persistent information separate from your operating system. When you choose to create a new data disk, several configuration options appear. For example, Azure initially suggests a disk name like VM01 Data Disk 0, but you can modify this to match your organization's naming standards. Next, you'll choose a source type for the disk. More often than not, you'll start with an empty disk for new data or applications, but you can also use existing snapshots or disks as your source, which is ideal for restores or replication purposes. You can then specify the disk size. However, it's important to note that the size you choose affects both storage costs and performance, so select a size appropriate for your workload needs. Again, you'll have the key management option available, which is typically set to platform-managed keys by default, simplifying encryption management. Another option called Enable Shared Disk allows multiple virtual machines to access the same disk simultaneously. This feature supports clustered or high-availability applications requiring shared storage. It's set to No by default unless your scenario specifically requires it. The Delete Disk with VM checkbox is also present here. This allows you to decide if your new data disk is automatically removed when you delete the virtual machine. In temporary deployments, selecting this can save resources, while in production, you might prefer to leave it unchecked to preserve the data separately from the VM. After configuring these options, clicking OK attaches your newly created data disk to the virtual machine, making it ready to format and use immediately upon deployment. And then finally, at the bottom of the Disks tab, you'll notice an expandable Advanced section, which offers additional optional settings. The first setting here is use managed disks. Azure uses managed disks by default, which simplifies disk management and offers built-in reliability and performance improvements. Managed disks also integrate seamlessly with Azure's availability features like availability zones. In fact, if you're deploying your virtual machine within an availability zone, this option becomes mandatory and is automatically checked for you. Below this, you'll see the option called Ephemeral OS Disk. Ephemeral disks are temporary operating system disks stored locally on the host VM rather than in Azure storage. This setup provides lower latency, faster deployment, and reduces costs, making ephemeral disks particularly suitable for stateless workloads or scenarios like virtual desktop infrastructure, where persistence of OS state isn't crucial. And with that, we've covered all available settings and configurations found on the Disks tab. Welcome back. In this lecture, we're going to review the settings available to you in the Networking tab when deploying a new Azure virtual machine. The Networking tab is where you'll define key network connectivity options for your virtual machine. This includes virtual networks, subnets, IP addresses, security settings, and load balancing options. You'll notice at the top of the page, under the Network Interface section, Azure allows you to choose an existing virtual network, or you can create a new one. If you decide to create a new network, you'll have to define an address space, which is essentially the range of IP addresses available to all resources within that network. Azure expects you to enter this in CIDR notation, so it would typically be something like 10.0.0.0/16. Within the virtual network, you'll also specify one or more subnets, which are used to break down the larger virtual network into smaller segments. What this does is help to logically organize your resources and control internal traffic. Azure suggests a default subnet, typically named default, but you can customize both the subnet names and address ranges to fit your needs. After configuring your virtual network and subnet, you'll choose a public IP address for your VM. By default, Azure automatically assigns a new public IP address, making your virtual machine accessible externally from the internet. However, you can also select an existing public IP or choose to have no public IP at all. You generally choose the none option if you don't need or want direct external access to the VM being deployed. The next setting is the network security group for the virtual machine's network interface. For this option, you have three choices. You have none, basic, or advanced. Selecting none applies no security rules during VM deployment, which can leave the VM exposed. The basic option applies standard security rules that are often suitable for general use cases. However, for more detailed control, the advanced option lets you configure custom inbound and outbound rules, giving you the most flexibility for securely managing network traffic. Below this, the checkbox labeled Delete Public IP and NIC when VM is deleted ensures that network resources created specifically for your VM are cleaned up automatically if the VM is removed. This helps avoid unnecessary resource costs, especially in testing scenarios. Enable Accelerated Networking provides enhanced network performance and lower latency. It's typically enabled by default on compatible VM sizes, offering improved throughput without additional cost. And then finally, in the load balancing section at the bottom, Azure allows you to choose whether your virtual machine will participate in load balancing. The options here include none, Azure Load Balancer, or Application Gateway. Selecting none means the VM runs independently without any load balancing. Choosing Azure Load Balancer allows you to either create a new load balancer or select an existing one to distribute network traffic across multiple VMs, including the one you're deploying. The Application Gateway option provides advanced features, including SSL termination, web application firewall capabilities, URL-based routing, and traffic management. By understanding these networking settings, you can more confidently configure secure, efficient, and reliable network connectivity for your Azure virtual machines. And with that, I'll see you in the next lecture. Welcome back. In this lecture, we're going to take a look at the Management tab as you would typically see it when deploying a Windows virtual machine in Azure. This tab includes important settings that help you manage things like security, identity, backup, disaster recovery, updates, and more. Let's walk through each setting in order as you would encounter them during setup. At the top, you'll see Microsoft Defender for Cloud. This is a security service that provides unified security management and advanced threat protection across your Azure and hybrid cloud resources. If you're using a subscription that includes a free security plan, you'll see a message showing that your subscription is protected, at least at a basic level. You can always choose to enable additional protections later on. Next is identity. Here you have the option to enable a system-assigned managed identity for your virtual machine. This allows your VM to securely communicate with other Azure services without needing to store credentials in your code. When this is enabled, Azure will automatically create and manage this identity for you. It's commonly used when the VM needs to access Azure resources like Key Vault, storage, or SQL. Right below Identity, you'll find Microsoft Entra ID, which was formerly known as Azure Active Directory. Enabling this option allows you to log into the virtual machine using Microsoft Entra ID credentials instead of a local username and password. This provides centralized identity management and is especially useful in enterprise environments where you want to apply role-based access control to manage who can log into the VM. It's important to note that enabling this option requires a system-assigned managed identity for the VM, so Azure enables that option by default if you turn this on. Following that is auto-shutdown. This is a cost-saving feature that allows you to automatically shut down the VM at a specific time each day to avoid incurring charges when the VM isn't in use. When you enable auto-shutdown, you'll specify the shutdown time and time zone. You can also choose to receive a notification before shutdown, giving you time to cancel it if needed, and you'll enter an email address to receive that notification. This is a great way to ensure development or test VMs don't run overnight unnecessarily. Below auto shutdown is backup. As you'd expect, enabling backup ensures your VM is protected against accidental deletion or failure. When you turn on backup, Azure creates and stores recovery points based on a schedule you define. As part of this, you'll need to choose a recovery services vault, which is the Azure storage container for backups, and you'll pick a backup policy that determines how often backups are taken and how long they're retained. For example, you can choose between standard and enhanced policies. Enhanced policies allow multiple backups per day and support longer retention periods, up to 30 days. You can also enable support for more secure workloads like trusted launch and confidential VMs, depending on the policy type. Further down, you'll see Site Recovery, which is Azure's disaster recovery solution. This allows you to replicate the virtual machine to another Azure region to ensure business continuity in case of a regional outage. When you enable Site Recovery, you'll configure a secondary region, which is typically a geographically distant region. You can also specify a secondary subscription if necessary. You'll also choose a recovery services vault for the replica and set a site recovery policy that defines replication frequency and retention. You'll need to configure options like availability, update settings, and automation account. Azure also allows you to let site recovery handle updates automatically. It's important to note that enabling site recovery can increase costs but provides an essential layer of protection for critical workloads. Below site recovery, you'll find options for guest OS updates. For example, you can enable periodic assessment to let Azure evaluate the update status of your virtual machine's operating system regularly. There's also an option for hot patching, which allows some Windows updates to be applied without needing to reboot the VM. However, this feature is only available on certain OS images and VM types, and Azure will notify you if it's not available in your configuration. And finally, at the bottom of the Management tab, you'll configure patch orchestration options. These settings determine how Windows updates are applied to the VM. You can let the operating system manage updates automatically, or you can choose Azure orchestrated updates for greater control over patch timing and sequencing. You can also opt for manual updates if you prefer to handle patching yourself. Most users stick with automatic by OS unless they have specific update requirements. Just keep in mind that the vast majority of these settings are optional. So with that, we'll wrap up here. I'll see you in the next lecture. Welcome to the Monitoring tab. Now, on the Monitoring tab, there are several options available to help monitor the health and performance of the VM you're deploying. First, you'll see the Alerts section where you can enable recommended alert rules. This allows Azure to automatically create alert rules based on common performance metrics such as high CPU usage, low available memory, or high disk IOPS usage. You can customize these rules further by clicking Configure. When you do that, you'll see a list of recommended alerts, including thresholds for CPU, memory, disk, and network usage. You can also specify how you want to be notified when these alerts are triggered, such as by email or mobile app notifications. Below that, in the Diagnostics section, you can enable Boot Diagnostics, which captures console output and screenshots to help you diagnose issues during the VM boot process. By default, boot diagnostics are stored in a managed storage account, but you can also choose to use a custom account if you prefer. If you select the custom storage account option, you'll need to either choose an existing account or create a new one. You also have the option to disable boot diagnostics entirely if you don't need this feature. Also within Diagnostics, you can enable OS Guest Diagnostics to collect detailed performance metrics and logs from within the operating system. For example, you can get info on stuff like CPU, memory, disk, and network utilization. Enabling this option requires a Diagnostics storage account where the collected data will be stored. If you haven't already created a storage account for Diagnostics, you can create one right from this screen by selecting Create New and specifying details like the name, replication type, and performance level for that storage account. And then finally, under Health, you can enable application health monitoring, which allows Azure to monitor the health of an application running on the VM by checking a specific endpoint. This is useful for scenarios where you need to ensure that a web application or API hosted on the VM is responsive. Once enabled, you can configure details like the protocol, port, and path to be checked. For example, you might specify an HTTP check on port 80 at the root path to monitor a web application. This allows Azure to detect if the application goes down and can trigger alerts or initiate automated actions in response. Ultimately, all these different monitoring options are designed to give you a visibility into the performance and health of your VM and any applications running on it, making it easier to detect and respond to issues quickly. Welcome back. In this lecture, we'll review the settings found on the Advanced tab when creating a new Windows virtual machine in Azure. On the Advanced tab here, we see that we can configure additional options for our virtual machine that help automate, customize, and optimize how the VM runs. The first option is Extensions, which allows us to install post-deployment tools and agents. For example, we can add monitoring agents to track performance, security extensions to protect against threats, or diagnostic tools that help troubleshoot issues. A typical use case for extensions would be automatically installing an antivirus agent like Microsoft Defender or a monitoring agent like the Azure Monitor extension without having to log into the VM later to set it up manually. By clicking Select an extension to install, we can browse and choose from a wide list of these tools. Next, we see VM applications, which lets us install full application packages onto the VM after it's deployed. This might include internal business apps or third-party software that our company uses. For instance, if you have a custom in-house application that every VM needs to run, you can create a VM application package that installs it automatically, saving time and ensuring consistency. Below that, we see custom data, which lets us pass scripts, configuration files, or other data into the virtual machine while it's being provisioned. A common use case for custom data is running a PowerShell script or a cloud init configuration that sets up the VM when it's first created, like installing IIS on a Windows Server VM or creating local users. Keep in mind, though, that the image used to create the VM has to support custom data for this to work properly. We also have the option to enable user data, which is similar to custom data, but is meant for scripts or configurations that need to be available to applications throughout the lifetime of the VM. A good example of user data is passing a script that an application on the VM might need to reference every time it starts. Unlike custom data, which runs once at setup, user data sticks around for ongoing use. But it's important to note that you should never store secrets or passwords here. Further down, we have performance, where we can enable higher remote disk storage performance for workloads that require fast read and write speeds. For example, if you're running a high-performance SQL database on this VM, enabling NVMe-based storage could drastically improve disk throughput and reduce latency. However, this option only works if the VM size supports NVMe, and if not, Azure will let you know. Next, there's the host section. This is where we can choose to deploy the VM onto an Azure dedicated host, which is a physical server in Azure that's reserved for our organization. This is useful in highly regulated industries like finance or healthcare, where data residency or compliance requirements dictate that your VM must not share hardware with other customers. It also gives more control over maintenance events and VM placement. We then have capacity reservations, which let us reserve compute capacity in advance. This is a great option if you know you'll need a VM with specific resources, like a large number of vCPUs or high memory, and you want to make sure Azure has it ready when you're ready to deploy. For example, if you're running a critical application that can't afford delays in deployment, capacity reservations ensure you don't get stuck waiting for resources to become available. Finally, proximity placement groups allow us to group VMs together physically close within the same data center to reduce network latency between them. This is perfect for workloads that need ultra-fast communication between virtual machines. Typical examples would be cluster databases, application servers that talk to backend databases, or financial trading systems where milliseconds matter. Once we've decided which of these advanced options to configure, we're ready to move on to the next tab to continue building our VM. Welcome to the Tags tab. In this lecture, we'll take a look at what tags are and why you use them. So the Tags tab in Azure allows us to assign metadata to the virtual machine we're deploying. Tags themselves are made up of name and value pairs, and they help us organize, manage, and track resources more effectively across our Azure environment. Think of tags as custom labels that make it easier to group and identify resources based on specific criteria. For example, we could create a tag called environment and set the value to production, development, or testing, depending on what we're using the VM for. Or we might add a tag called department and set the value to finance, marketing, or IT to indicate which department owns the resource. Other common tags include project, cost center, and owner. These tags are incredibly useful for several reasons. First, they make it easier to search for and filter resources inside the Azure portal. So when you have hundreds or even thousands of VMs, you can quickly find what you're looking for based on a tag. Second, tags are essential for cost management and reporting. This is because Azure Cost Management can use tags to break down and analyze costs by department, project, or environment, so you know exactly where your cloud spend is going. For example, if you tag all VMs for a specific project with project XYZ, you can easily generate a report showing how much that project is costing you in Azure. A real-world example of using tags might be a company running virtual machines for multiple clients. By tagging each VM with client Burke's Lighting, client Atlas Desks, and so on, they can track and bill each client for the exact amount of Azure resources they are consuming. Another example could be an IT team managing virtual machines across different regions and environments. In this case, they might tag VMs with region East US and environment production so they can filter and manage those VMs together when needed. Once we've added any tags we want to apply, these tags will follow the VM and can be viewed or modified later under the resources properties in Azure.